Welcome and thank you for your interest in the CEWASTE project, a voluntary certification scheme for waste treatment. My name is Otmar Deubzer. I'm from the United Nations University and I will give you some introduction of this CEWASTE project. What is the background of this whole thing? As we know, the recycling rates of most critical raw materials in the EU are very low and also outside the EU. At the same time, recycling could at least mitigate the criticality of these critical raw materials. What we see that there are standards evolving in the EU about declaration of use of CRMs, and we have standard for waste collection of WEEE, transport and its treatment. But what we do not see anywhere is a standard and a certification scheme for the collection, transport and treatment of WEEE and other products which contain critical raw materials. So this is the gap we want to fill as a contribution to sound CRM recycling. So the question was, which CRMs can be actually recycled from which products? So we tried to identify the key CRM equipment, the KCE. First, we defined criteria for identification of these KCE. So the first criterion is clear, it's the material focus. Of course, we focus on the critical raw materials. The latest list still is the 2017 one. So this is these are the materials we want to go for. Which are the products? There are, of course, a wide range of products, but we focused on WEEE, on batteries from WEEE, and on end-of-life vehicles, ELVs. Final processing, of course, must be technically feasible. So if the CRMs cannot be recycled from certain products, technically, if there is no final treatment available, then it doesn't make sense to go for recycling. This requires technology readiness level of at least 7. Another thing is that each final processing technique also needs a certain input which it can process. So it must be clear that pre-processing processes can actually provide the inputs which are required for the end processing. And also important, the CRM recycling should not conflict with precious metal recycling. So either if you have to decide whether you recycle the one or the other, we don't want to disturb the PM recycling because this is the economic driver of CRM of recycling in the WEEE and battery sector. So, of course, economic criteria could also be or certainly play a role. However, we decided that the fact that something is economically not feasible under the current economic framework condition is not an exclusion criterion. Why not? It's the economic framework can be changed. So this is what we did once some years ago when we introduced the WEEE directive and where the EPR approach provided stable financing of WEEE, which could before not be processed for economic reasons. Then, of course, for recycling, the concentrations are a crucial parameter. We said, okay, the CRM concentration must at least be within a reasonable limit. This is difficult to define for each product, but to demarcate it from others, we excluded the hopeless cases where we said, okay, this is beyond the reasonable limits. Criteria for such hopeless cases are if the concentration or the content of CRMs is either below technical limits, so that it's even if you bring it in a process which is capable of recycling certain CRMs, it can't happen for thermodynamical reasons or others, or if it's still very low even after the separation of the components, even though maybe be over the technical limits. We think that in such cases there's a severe imbalance between the required effort and the benefit. Prominent victims and examples for hopeless cases are in our case then tantalum capacitors. They are very small, they contain tiny amounts of tantalum, and it means you would have to remove them from the printed circuit boards, either to bring them to a tantalum recycling cycle, or you put the entire a printed circuit board into a tantalum capacitor, tantalum recycling process, which means that all the precious metals would be gone. So this is not what we want. So this is one example of a hopeless case. What is also excluded is lithium, even though many wanted it to be included, but we said, okay, for the time being, keep to the CRM list, and should this change, should a new version of this be published within the next weeks or months, then we can still add it maybe to this to the list, or to the we can go for recycling of this CRM as well. So what are the KCEs? These are, first of all, products with neodymium iron boron magnets, from which we can recycle either rare earth elements, or we can produce new magnets in a magnet-to-magnet recycling process. So where do we find them? They are contained in large household appliances. They are also there that we find them in the engines and drives from approximately the more or less 2006 models on. This became more accustomed to use such permanent magnets. Then in electrical vehicles, so we find them of course in the engines, and there they are pretty heavy and big even. And then in the ICT equipment, information and communication technology, in the hard disk drives, in the optical disk drives. So this is where it can be gained from, and unfortunately, at the time being, this is not commercial, not feasible economically. So there are no commercial activities in the EU. However, we have several research projects ongoing in and outside the EU. We have pilot processes installed which are still tested, and we simply think that if there is an offer of such magnets and sound financing, then the technology will very soon be major to apply it in an industrial scale. Then TVs and monitors, they contain fluorescent powders, which is our second, which we also want to recycle. In the cathode ray tubes. This is for rare earth element recycling. We also find them in the fluorescent lamps, and this is a process that was commercially practiced until around 2015 by Rhodia in France, but they had to stop the operation because the prices of the rare earth elements had dropped. So the whole thing was no longer commercially feasible. But at least what we know in this case, it's the technical feasibility is proven. Then recycling of CRMs from batteries. Here we had a look at the combustion vehicles. They contain the lead-acid batteries, which contain antimony, which is a critical raw material and which can be recycled from these batteries, which this is something which is already happening, so it's a commercial activity. The same applies to lithium-ion batteries from electrical vehicles. So there is a commercial process to recycle the cobalt from these lithium-ion batteries. And what is in principle, they contain also rare earth elements, but these cannot be recycled under the current economic conditions. Lithium actually can be recycled, and it already happens, however, mostly from cobalt-rich lithium-ion batteries, because the lithium can only be co-recycled with cobalt also for economic reasons. So then we still have palladium and other valuable materials. So yeah, we find them in highest concentrations in ICT equipment, mostly located on the printed circuit boards, and there is something we don't have to care so much, because this is a daily bread and butter business of the recycling industry to recycle precious metals of all kinds for economic reasons. Still, there is improvement potential in better collection, good pre-treatment, and we need to exclude unsound end treatment, which in some parts still happens. So this is what we want to address in the requirements. We analyzed around 60 normative requirements, standards, legislation, and so on, which we thought might be of relevance for KCEs. What we found generally is that there are a lot of relevant non-technical requirements available already, which we can use, like EHS, environmental health and safety, tracking, documentation. There are, however, very few CRM-specific non-technical requirements, very few technical requirements with relevance for KCEs, like the removal of PCBs in the WE directive, of batteries, which is a first step towards CRM recycling also. But we hardly found any technical requirements which are somehow specifically for CRM recycling. So in the end, we decided that we would take as a reference the EN 5625 standard for retreatment, collection and transport as a general reference. So we use whatever we can use from this one. Then we fill the gaps, and the largest gap, of course, are the technical requirements for the CRM recycling, which have to be developed. The most severe obstacle is that there is no sound and reliable financing mechanism available, but it's clear. So all this can only happen if we change the framework conditions. If we want this recycling of CRMs to happen, then we must pay for it. Before I come to the end, I would like to point out the two more papers about this topic. So there's a presentation of Sonja Valdivia about the CEWASTE requirements, and of Hifat Baron from Öko-Institut about the CEWASTE assurance and verification system. With this, I thank you for your attention and wish you a great day. Bye.